Good day again, everyone, and welcome back to the second part of our lesson. Today, we will talk about simplifying radical expression using laws of radicals. Let's start. Before we start simplifying radicals, here are the laws of radicals which will be needed to manipulate and simplify the radical expressions effectively. Let Mn. Before we start simplifying radicals, here are the laws of radicals which be useful to manipulate and simplify the radical expressions. Let Mn are positive integers and Mn are real numbers such that the nth root of b and the nth root of b exist. Then the nth root of a raised to the power of n is just equal to a. Example, the square root of 5 raised to the power of 2 is 5. Then the nth root of a raised to the power of n is just equal to a if a is equal to greater than 0. Example, the cube root of 27 is equal to the cube root of 3 cube, which is equal to 3. The nth root of a to the n is equal to a if a is negative and n is odd. For example, the cube root of negative 125 is just equal to the cube root of negative 5 cube, which is equal to negative 5. Another one is the nth root of the product AB is just equal to the nth root of A times the nth root of B. For example, the square root of 2 times square root of 8 is equal to the square root of 16. Since 16 is a perfect square, so this is equal to 4. Next is the nth root of the quotient A over B is just equal to the nth root of A over the nth root of B, where B is not equal to 0. For example, the fourth root of 162 over the fourth root of 2 is just equal to the fourth root of 162 over 2, which is just equal to fourth root of 81. But 81 is 3 raised to the power of 4, so using number 2, this is just equal to 3. Another one is the nth root of the nth root of A is just equal to the product of the index Mn of A, which is also equal to the nth root of the mth root of A. For example, the square root of the cube root of 4 is equal to the sixth root of 4 since 2 times 3, or this is also equal to the cube root of the square root of 4. But square root of 4 is 4, so this is the cube root of 2. Okay, a radical of index n is said to be simplified form or simplest form if first, all perfect n powers have been removed from the radical, no fractions inside the radical, no radicals appear in the denominator of a fraction, and the index of the radical has been reduced as small as possible. To meet conditions 2 and 3, rationalize the denominator by multiplying the expression by an appropriate form of 1 that eliminates the radical from the denominator. For example, simplify each radical. Square root of 50. So first we have to factor the radicand, so which is 50 is 25 times 2. Using apply the law of radicals for the product. So this is square root of 25, but 25 is 5 square, so the answer is 5 square root of 2. Another example, the cube root of 16 x to the 7. So factor the radicand, perfect cube, which is 8 times 2. So we have 2 cube. Again, x to the 7, factor the perfect cube, x cube. Again, x cube times x. Then simplify the radical, so factor out the perfect cube, 2 times x, so we have 2x squared. Then cube root of 2x. Another example, number 3, the square root of 2 over 3x. So again, this is not in simplified form, so we have to rationalize the denominator by multiplying an appropriate form of 1 to eliminate the radical from the denominator. So the appropriate form of 1 is 3x over x, which is the denominator will become 3 square x squared. So the denominator is now the radical, this is perfect square, 3 and x. So the final answer is square root of 6x over 3x. Number 4, the fourth root of 64. So we have to reduce the index. This is equivalent to the square root of 64, but square root of 64 is 8. So the factor the radicand, 8 is 4 times 2, which is 2 squared times 2, but square root of 2 squared is 2. So the answer is 2 square root of 2, which is now the simplest form of this radical. That's it for our lesson on simplifying radical expression using laws of radicals. Again, this is Jake Albia, and thank you for listening and have a good day.